Hey, so we are going to read about energy and speed today. I'm going to go ahead and read out loud, and if you can just follow along, that would be awesome. So today we're talking about energy and speed, and we're going to start right up here at the top. So, what is the relationship between energy and speed? A battery can have a lot of energy, but it also sits on a shelf, not moving. You might feel like you have a lot of energy but be sitting still. When you put that battery in a toy car, the car can start to move. When you get on a bike, you can turn a lot of that energy into speed and motion. So I can kind of relate that to kind of what we're doing right now. I know we're spending a lot more time sitting. I know I am. And so I still have that energy, but I'm sitting still. So I'd have to put that energy into motion. So let's say you go out and ride a bike a long way. Have you done work because you went for a ride? Energy is defined as the ability to do work. Work is what is done when a force changes an object's motion. To do work, you must apply a force. A force is a push or pull. When you ride a bike, you use energy. You apply force to the pedals, which moves the chain. The chain moves the wheels, and the bicycle moves. The energy you use generates a force that causes the bike to move. Because the bike is moving, you have done work. So if you look here at the picture at the bottom, it says riding a bicycle uses energy. That means it is work. So anytime you're using energy, you are accomplishing work. All right, so if we look over here on the next page, we're going to talk about speed. So energy takes many forms. A common form of energy is kinetic energy, the energy of motion, which is what we talked about several weeks ago. All moving objects have kinetic energy. Motion is the change in an object's position over time. When you think of kinetic energy, you think of something moving. The rate of an object's change in position over time is its speed. To calculate the speed of an object, you must first measure the distance it travels and the time it takes for the object to travel the distance. Then divide the distance traveled by the time the object travels. Units of speed are units of distance per unit of time, such as meters per second, kilometers per hour, or miles per hour. So when you go on a trip and you're on the interstate, your parents might be driving 60 miles per hour. So that would mean that in an hour, you could travel 60 miles. So if you look here at the bottom, it just gives you some different examples. And it says these are the fastest speeds of animals over short distances. So you can just kind of take a minute and look through those. Okay, so the last thing we're going to talk about is measuring speed. So let's look at an example. Say you want to know the speed of a car as it drives through your neighborhood. You need to measure two things, the distance the car travels and the time it takes the car to travel this distance. So the distance between the beginning and end of the car's path is 200 meters. The car traveled this distance in 20 seconds. What was the car's speed? So just think about that for a second. So you have 200 meters and the car traveled this distance in 20 seconds. So you can calculate that by doing the distance divided by the time. So the distance is 200 meters divided by the time, which is 20 seconds. So the answer would be 10 meters per second. If the car has to go faster to enter a highway, the driver changes speed by pressing down on the accelerator. The speed of the car increases as more energy is expanded to move the car. If the car enters a school zone, the driver will press on the brake pedal. The speed of the car decreases. Energy is used to slow down the car. So this is something that we use every day, especially when you are in the car, riding your bike. You're definitely using this. You're going a certain distance in a certain amount of time. So we're going to continue talking about this in our next activities.